2/27. All right, so numerical fractions. Just making sure that we have the base case down so that we can make it harder with polynomials. 4/7 minus 2/7, shout it out, is? 2/7. Not correct, yeah. So it has the same bottom. It has the same denominator, so you have like denominators. So whenever you have like denominators, Chris, can you please move? Thank you. Whenever you have like denominators, you just add or subtract the numerators, keep the denominator, right? So add / subtract numerators and then don't touch the bottom. The bottom did not change. We left it as a 7. This is going to be the same case. Chris, I'm trying to teach. This is going to be the same case when I have polynomials on the bottom. I'm not going to touch the bottom. I'm not going to touch the denominator. Yeah. What's up?
Why aren't you writing over there?
Because I like being up on the board more.
I like when you're over there. Yeah, I like when
Really?
No, I'm just, I like how
I don't really care.
You know what I like? You do you.
I do me? Okay. I can continue going from
you're so mean.
right down here.
Can you wear the hat to go up there?
Yeah.
I can wear the hat and be up there.
Yeah, that works.
Okay.
Now I feel like
Wait, you want to
All right. So let's do example 1.
Wait, can you go back down? I wasn't paying attention.
Sorry, you're going to have to get it from someone else. All right. So example 1. We have like denominators. The bottom polynomial is the same. Therefore, I can just add the tops. So, quiet raised hand. You're going to raise your hand with your participation card in your raised hand if you want to participate here. James, do it for us.
The top is 5x.
5x. He's lying to you. 11. 5x plus 11 for the numerator, and the denominator, James, is? X plus 3, that is correct. X plus 3, box it. That's our final answer. Pretty easy so far, yeah? All right.
Wait. Dude, I'm so lost. Wait, hold on. What did you just do?
So we added the tops. 2x plus 3x is 5x. 4 plus 7 is 11. Didn't do anything to the bottom. Didn't do anything to the denominator. So far, so good, Chris? You're caught up?
Wait, why is the bottom?
because you're adding.
You don't.
All right, example 2, quiet raised hand. We'll go with Eva.
6x plus 16.
So 6x,
Oh, I mean 4x.
4x, yeah, we're subtracting. 4x,
Oh,
Would it be plus 2 if the negatives cancel out?
ooh, plus 2? I don't know.
Or would it stay negative?
So when you have a negative, you're really distributing the negative into each of these terms.
So it's negative.
It is going to be a negative 2. Negative 2. And the denominator, Eva?
2x minus 1.
2x minus 1. Oh, look at that. We can reduce this.
okay.
Oh,
We can.
Wouldn't it be 2
Over
x
one?
over x?
So let's factor the top. Who can factor the top for me? Quiet raised hand. Do you have your card in your raised hand?
Dude, I have to hold it?
You have to hold it up. I see Stego's card.
Wait, what? So, what?
All right, Stego, factor the top. 2 all over 2x minus 1. And what cancels out, Chris?
Wait.
Hold up. The 2x is in the thing.
The 2x minus 1 things, exactly. And I'm left with just 2. The answer here is just 2. So far, so good?
Watch, it's easy enough. Once we get to the back is when we have to do something.
Just 2. The answer is just 2. So I can write here, that's equal here, and that's equal to 2, box 2. All right. Now we're going to go to numerical fractions where we have unlike denominators. Here we go. Yeah. All right, so, what do I do? Gio.
Oh, really? All right. You multiply the 1/3 by 2.
By 2 over 2. Okay, and then this is going to be, I'm going to rewrite this all out. So this is now going to be 2 over 6 plus 1 over 6, which is therefore equal to what, Gio? You reduced it already in your head. Great job. 1/2. Good job, Gio.
Wait, why'd you get 2?
Why did we multiply by 2?
No. Like, why'd you get
1/2.
Why did I get 1/2?
No.
You see it? 3 over 6 reduces to 1/2.
Not like that. I'm not even the other way.
Okay. So sometimes we only need to multiply one fraction. Some cases, like this next case over here, some cases we're going to have to multiply both fractions.
Oh, right.
We're trying to get like denominators. Quiet raised hand with their card in the raised hand. Who wants to try this next one? Fiona? By just 5 or 5 over 5? 5 over 5. And the second one by 3 over 3. And this is now going to turn into, oh, you're already doing it in your head? That's awesome. So 11 over 15. Yep.
Wait, how'd you get? Oh, you could use after you.
5 plus 6 for the top is 11. Bottom is 15. All right, so the general steps for unlike denominators.
Just multiply together.
Get like denominators. I'm going to just say DEN for my notes because I don't want to spell out denominators. It takes too long. Get like denominators. Then do like before. And when we were getting like denominators right here, we were really multiplying the top and bottom. Multiply top and bottom. So far, so good. Let's see if we can apply these same skills to polynomials now.
Dude, that seems just like a YouTuber. Just like, you guys' mic, you
All right, example 3. What am I going to do? What am I going to do to get like denominators? So I'm looking for a quiet raised hand. There's only a few people that have cards out. I think Teflon has her card out. But I'll still call on a quiet raised hand if there's no card. No card, no card. Stego, go for it.
So they're not the same bottoms. You're going to multiply the first one by negative 4.
By -4. So if I multiply this by -4, let's just play this out. Let's not write this down quite yet until we know that it's... So -4 like that. So when I multiply by -4, this is going to be -4x minus 4. So how are we going to turn this into -4x minus 4?
Add negative.
Or multiply it by 4 and then multiply it by negative.
Yeah. So it's a good attempt. Good attempt.
Oh, wait, you just erased it?
So here's the key. When we were multiplying, or when we were trying to add 1/3 and 2/5, these two numbers were not the same at all. The thing that I was missing from 3 was the other denominator. The thing I was missing from 5 was the other denominator. So multiply by the other denominator. So who wants to tell me exactly what to do for example 3? I'm still going to give preference to people that have cards. Chris.
So, that you do x minus 4, and the other one you do x plus 1.
And x plus 1. Like that? Okay, there it is. Now we're going to actually have to write out what this is. I don't have enough room to write out to the right-hand side, so I'm going to do it underneath down here. So I'm going to distribute this 3 into this x and this minus 4. When I distribute that 3, I get 3x minus 12. And the denominator, as a general rule of thumb, unless I explicitly, or unless Con explicitly tells you to multiply out your denominator, leave it factored. Don't multiply it. Don't multiply. Just leave it as easy as possible. Leave it x plus 1, x minus 4. Don't multiply them together. Leave them factored. Next one. When I distribute the 2 into the x plus 1, Teflon, did you want to get your card in? No? Someone shout out what to do. Yep, distribute the 2, so 2x plus 1 plus 2 all over, and then it's the same factors. It's x plus 1 times x minus 4. Now the denominators are exactly the same. We have like denominators. What do you mean erase everything? Now that we have like denominators, I can combine this into one fraction. I need to add those tops. Who can do that for us? 5x minus 10, and on the bottom it stays the same. X plus 1 times the quantity of x minus 4. There's our final answer. The one tricky thing that you might encounter is we might need to factor this. So if I factored the numerator, I would get a 5 and an x minus 2. This numerator here factors as 5 times x minus 2. You need to look to see if anything can cancel out. X minus 2, x plus 1, x minus 4, nothing could cancel out.
So if it doesn't cancel, you just leave it like that?
Just leave it like that. But always check if it can be factored.
Gotcha.
Let's go on to the back. I should hear people flipping over their paper. Okay. So far we've been in the land of easy fractions. This is a Khan Academy level question.
I'm feeding him.
All right, quiet raised hand. What am I going to do? I'm looking for a quiet raised hand. What should I do to this problem?
You need to find.
All right, I'm going to have to cold call on Teflon because she doesn't want to participate. Sorry. Tell me what to do, Teflon. Yep. What am I going to multiply the top and bottom of this left fraction by? (6a) like that? 6a squared like that? Yeah, you're right. We're missing a 6a squared. Teflon, what am I going to multiply the right fraction by? A plus 2, the other denominator. A plus 2. A plus 2. All right, then I need to actually multiply these out and simplify. So thank you, Teflon. I need to multiply them out, so what am I going to do? Who wants to help me out? We have to distribute. Gio, go for it. Gio's going to do the left one, and then someone else is going to do the right one. I'll do the denominator for you. I'll be really nice. Ready? A plus 2.
Thank you.
6a squared. You're welcome. That was the hard work. Whew, I feel better. I got the hard stuff out of the way. You can do the easy part at the top.
18a to the third.
18a to the power of 3, like that?
Yeah.
Okay.
Minus 6a to the square.
6a squared. What do you guys think? Thumbs up, thumbs down? Did he get it right? Let me see thumbs. Yeah, he got it. Good job, Gio. Solid, man. Okay, so I'm going to add that with, okay, I'll do the hard part for this next one. A plus 2. Whew. That was hard. I was going to mess up there. All right, Eva, do this one for me.
2a squared
2a squared
minus 2.
minus 2. There's an error up there. See if you can find it, Eva. It's your error to catch, but other people can get it too. And it's a hard error to catch. So
Oh, do I have to do the box thing?
you do have to do the box thing. Yes. All right. It's a general rectangle. Here is the box thing. 2a minus 1. That's a great question. I'm going to come back to that. That is a perfect question. 2a minus 1 and a plus 2. Why do I have to do this box? The answer to that is going to be answered by one of you. Why do we have to do the box? Someone else answer. Why do we have to do this box? Eva knew she had to do the box.
I don't know. I just knew I had to do the box.
Someone try to, yeah, so Gio or Fiona, who wants to do it?
You can take it.
Okay, Fiona, go for it.
I think I'm right.
Yeah, whenever you're doing 2 and 2, or 2 and 3, or 3 and 3, anything that's bigger than 1 and 2, anything bigger than 1 and 2, either way, is going to need a box.
That doesn't make any sense.
So this is bigger, yeah?
So if it was 3 and 3, you'd have to make
This is bigger. 2 and 2 terms. I have 2 terms and 2 terms. So I need a box. If it was just 1 term, you can just distribute. But since I have 2 terms, I have to do this advanced distributing using the general rectangle, or using the box. Eva?
I have
You're ready to fill it in? Okay. A times 2a,
2a squared.
negative 1 times a,
Negative a.
2a times 2,
4a.
and finally,
Negative 2.
negative 2. And you add those all together, combine these like terms on the diagonals.
It's going to be
2a squared plus 3a minus 2.
Minus 2. There it is. Good job, Eva.
Or you just leave it like that?
You leave it like that until we add it. All right. Make sure that we really understand what's going on. I'm going to pause until I see most people stop writing and have some time to think. Whenever I have a binomial times a binomial or anything larger than that, you do need a general rectangle, also known as a box.
You make another one?
Say again?
You need to make another box?
I need to make another box for, not for example 5. I won't need a box for a while. You shouldn't be eating in the class, Chris.
I'm the only one.
You shouldn't be eating in the class either, Stego.
You see, that's a bad example.
Whoa,
because
you're
I was like,
drinking?
She's eating. I could eat.
Yeah, no one should be able to eat. All right. You're going to get me in trouble, guys. All right, what am I going to do?
add it.
I need to add it. Can I add it? Am I allowed to now?
Yeah.
I am. Why?
You can, but you have to add like the same
Oh.
terms.
the same term, yeah. Like,
Yeah, because I have the same.
Denominator.
Yeah, once I have like denominators, I have the same denominators, then I'm allowed to add. All right, so James, do this one for us. So we have a 2a squared and a negative 6a squared. Negative 4a squared, solid. Keep going on.
Oh, I didn't even see the 3a.
Good job. And I'll do that hard part, the a plus 2 times 6a squared. And can we factor that top term? We might be able to factor by grouping. I can already tell you that if we factor by grouping, it's not going to work out.
Yeah, because those are 3 right there.
The way that I see that it's not going to work out is if I group that second term, 3a minus 2, it's simplified. I can't factor anything out of it, which means a multiple of 3a minus 2 has to be here. There's no 3a minus 2. This is not 3, this is not 2. So there's no way to factor this by grouping. That's our final answer. Box it.
Dope.
It is pretty dope. Our final example, example number 5. When Miss Sasson comes in, I'm just going to be like, I told him 3 times. What am I supposed to do? All right, so example 5. How do I do it?
I got you. So you multiply that one by 3z plus 2.
3z plus 2 just on the top, like that? Oh, and on the bottom. 3z plus 2.
And then on the other side you do 2z minus 1.
2z minus 1. 2z minus 1. All right.
And then you gotta do that.
I'll do the hard part for you. The 2z minus 1. The 3z plus 2. That's the bottom. That's going to be adding 3z plus 2 and 2z minus 1. Just as a note to all of us, it doesn't matter the order in which I put the denominator. There's something called the commutative property of multiplication, or commutative property of multiplication. It just means that you're allowed to switch the denominator. So these are actually like denominators, even though they don't look perfect. You're allowed to add these two. All right, who's going to do this top left, the numerator of the leftmost fraction? Let's give it a geo.
18z to
18z to the 4th?
yeah, and plus 12z
12z
to the 3rd.
to the 3rd, like that?
Yeah.
What do you guys think?
Am I getting points for this?
Yeah.
All right, let's give it to someone new for the top right. Can't be Chris, can't be Gio. They've been participating a ton. We'll give it to James.
5z to the 3rd. Oh, wait. Don't you have to pop?
You could do a box if you wanted to, but you don't have to. The box will always work for multiplication, always.
5z to... Oh, sorry.
I messed up. No, never mind.
10z to the 5th.
10z to the 5th.
To negative... You guys have tasters on?
Negative 1 times 5z to the 4th.
I need to do
Yeah.
Ew.
Minus 5z to the 4th.
Yeah,
All right.
like you get that juice in
All right. We have like denominators.
Yeah.
Saliva?
I love the tangent conversations that we're having. It's very interesting.
Whatever you just ate, it tastes just like that, so you have like...
All right. I need someone to finally simplify that numerator. Fiona, go for it.
10z to the 5th plus 13z to the 4th plus 12z to the 3rd. All over 2z minus 1 times 3z plus
Times what?
Wait, it was just an idea of pencil, but this shit doesn't work.
Yeah.
Oh, that's
Oh, yeah. They do run out of ink pretty fast. Here's this pencil. No, you want that pencil? All right. All right. And can we factor the numerator? You're praying to God that it doesn't work, right? Let me actually check.
You can.
120 and 13. What are the factors of 120? 40 and 3. You could do
No, this
2 and 60 closer together.
no.
I don't see anything working.
Yeah, me either. Just box it up.
Okay. I think that's as far as we can get. You could factor out a z to the power of 3, but that's not going to do anything.
It's too much.
All right. Are there any questions before you begin your summary, which is closely followed by your Khan Academy assignment?
This, I did all my work.
I saw that you did most of your work, yes.
I did all of it.
You did most of it, yes.
I did all of it. Dude, what do you mean?
Did you work on it at lunch?